Good evening, all. In previous sessions, we discussed what is the DevOps, what are the advantages of DevOps, what are the advantages of DevOps, what is SDLC, what are the SDLC phases, software development lifecycle, how a project will be developed in the IT industry. We understood those SDLC phases like requirements gathering, analysis, design, implementation, testing, deployment, delivery, and maintenance. All these things comes under SDLC phases. And we discussed about what is waterfall methodology. Waterfall methodology is the first and foremost methodology that we use it to follow to develop the software applications for the people. Okay, waterfall methodology we discussed. Waterfall is a linear methodology. Everything will happen step by step. We will go only in the forward direction. We will not go in the backward direction when we go for waterfall methodology. In today's competition world, waterfall methodology not suitable. That's why we are going to use agile methodology. Agile is a linear methodology, or agile is a iterative methodology. Agile is an iterative approach to develop and deliver the projects. Nowadays, client interaction should be more in the project development. So we are going to develop and deliver the project in the multiple releases by using agile methodology. This DevOps culture will help us to achieve agile methodology. Right. Easily we can develop and deliver applications quickly to the clients by using this agile methodology. Very good. Now let's talk about DevOps tools overview. DevOps tools overview. DevOps is a culture which is used to collaborate the developers and operations team in the application. Guys, in the real time, what are the tools we are going to use to implement DevOps process? DevOps is not one person job. DevOps is a teamwork. The main aim of the DevOps to collaborate development and operations work in the project. In order to collaborate, development and operations work in the project, we are going to use several tools. What are the tools we are going to use here? We are going to use build tools. We are going to use build tools. Then next we are going to use some repository tools. Build tools are required. Repository tools are required. Then next one, we need some code review tools. We need some code review tools. And the next one, code deployment tools. Code deployment tools. And the next step, code deployment tools are required. After that, we need configuration tools. We need configuration tools, and we need containerization tools. Containerization tools we are going to use, and we are going to use orchestration tools. We are going to use orchestration tools, and we are going to use the monitoring tools. Monitoring tools will be available. If you want to work as a DevOps engineer, then you need to understand these tools: build tools, repository tools, code review tools, code deployment tools, configuration tools, containerization tools, orchestration tools, and monitoring tools also required. Okay, here, what is the purpose of build tools? What is the purpose of build tools? Here, guys, coming to build tools, we have Ant. Ant is one build tool. Then Maven is one build tool, and Gradle is one build tool. Like that, there are so many build tools are available. Projects will use any one of the build tool. Ant tool became outdated in the market. People will use Maven or Gradle as a build tool. Next one, coming to repository tools, SVN is one of the repository tool. SVN, GitHub, SVN, GitHub, and Bitbucket people will use as repository tools. Code review tools, we have Sonar Cube or PMD is available, which is a programmer mistake detector. Sonar Cube is available, we can use. Sonar Lint available. This is also we can use as a code review tool. Code deployment tools, we have Jenkins, we have Jenkins, we have udeploy. Like that, there are so many tools available in the market. Out of them, Jenkins is the most famous code deployment tool we are going to use in the project. Configuration tool, earlier people used to work with Chef, but nowadays people are going with Ansible for the configuration management. Containerization tool, earlier we have nowadays we are using this Docker as a containerization tool. Orchestration we are going to use by using Kubernetes. Kubernetes is a orchestration tool and Docker is a containerization tool. Monitoring tool, we have some Negios, we have some Grafana, Prometheus. Like that, there are several tools are available. Negios is available, Grafana is available, Prometheus is available, ELK is available in order to do the monitoring of our application. If you know all these tools, then you can implement DevOps culture for your application. In the coming classes, we are going to work with these tools, guys. In the coming classes, we are going to work with these tools in order to develop our applications by using DevOps culture. So DevOps is a technology or DevOps is a process? DevOps is a technology or DevOps is a process? Could you please tell me? DevOps is a process. Okay. And we need to know one more tool that is called as project management. Project management tool will be available. Project management tools, which is called as Jira. Jira comes under project management. How the work will be allocated to you in the company, how the project work will be managed in the company, that we will do that work management we will do by using a tool called Jira. Jira is the project management tool. Bamboo also comes under project management. Bamboo also comes under project management. Here we are using Jira. We are using as a management tool. We are using Jira as a project management tool. Just look at the names of the tools. Bamboo is for project deployments. Yes, Bamboo deployments. Like Jenkins, we can do that deployments. Build tools, Ant, Maven, Gradle comes under build tools. Repository tools, SVN, GitHub, Bitbucket, they are repository tools. Code review tools, PMD, SonarQube, SonarLint comes under code review. Cloud deployment, Jenkins, udeploy. People might use, some companies are using Bamboo as a deployment, like instead of Jenkins, they can use the Bamboos also. Bamboo tool also they can use for the deployment. But Jenkins is the most famous tool in the market. CI/CD we can achieve by using Jenkins. Continuous integration, continuous delivery. For that purpose only we are using Jenkins. Configuration tool, that is Chef or Ansible, will be used for configuration management for our application. Docker is a containerization tool for our application. Kubernetes is orchestration tool for our applications. Grafana, Nagios, all these things are ELK stack is used for monitoring purpose. Project work management can be done by using Jira. Project work management can be done by using Jira. Got it. Fine. Let us try to understand the overview of these DevOps tools. Let us try to understand the overview of the DevOps tools. First one, guys, here developers will be available. Developers will be available in order to develop the code. Developers will be available in order to develop the code. Now, developers, multiple developers will be available in the team. It is not about one developer, guys. Multiple developers will be available in our project. Multiple developers will be available in our project who will develop the programs, maybe Java, maybe .NET, maybe Python, maybe Angular, maybe React, like that. Multiple team members will be available in our application who are going to develop the application. Now, in order to develop that application, they need to create a project. In order to develop the application, they need to create a project. Now, all these developers will use build tools and they will create a project. All the developers will use build tools to create the project. They create the project by using Maven. Developers are going to use the build tool. By using these build tools, they are going to create the project. What is the build tool? Maven is the build tool. By using this build tool, they will create a project. They will create a project, a folder structure. They will add all the dependencies by using this Maven. These development team members are going to use this Maven as a build tool and they are going to create the project. By using Maven, the project will be created. Now, assume that this is the project that they have created by using Maven. This is my project application. Application will be created by using which tool, guys? Application will be created by using a tool called Maven. Maven is a build tool which is used to create the application, and whatever the dependencies like jar files which are required for our application, those things also will be created by using this Maven software. Maven is a build tool. Once these developers created the project by using Maven, then these developers are going to write the programs in the application. Some assume that it is a Java application, then all the developers will create the code, Java classes they are going to develop. Guys, observe carefully here. Developers are available. In the project, multiple developers will be available. In the project, multiple developers will be available. These developers will create a project. In order to create the project, they will use Maven or Gradle. That is a build tool. Project structure will be created by using build tool. Where should be the source code of the application? Where should be unit test code of the application? Where should be configuration files of the application? Where should be dependencies of the application? That project structure will be created by using a build tool. Some people will use Maven as a build tool. Some people will use Gradle as a build tool. Ant got outdated. Ant got outdated. Maven is a build tool, which is a open source. Project structure will be created by using Maven. Once the project structure is created, inside that project, these people are going to develop the programs. Java classes will be created. Java classes will be developed by using this Maven build tool. Source code will be created. That code will be compiled. That code will be packaged by using Maven project creation. By using Maven, they will do project creation, project compilation, project compilation. That means project building. The Java files will be available. Java files should be converted into .class files. Project compilation, unit test execution. Unit test execution also will done by build tool. Then packaging. Packaging also will happen. Either jar file or war file also will be created by the build tool. What the build tools are going to do in our project? Dependencies downloading. Dependency downloading. Dependency downloading also will done by build tools. My project want to use the Spring. I want the Spring jar files. So this Maven is going to download the Spring jar files. My project want to use the Hibernate. These dependencies will be downloaded by the Maven. Guys, when I am using a Maven in the project, what is the duty of the Maven? How the developers will use this Maven software? Developers will use the Maven software to create the project structure. And this Maven will be used to download the dependencies are downloading. In my project, I want to use several concepts. Spring I want to use, Hibernate I want to use, REST API I want to use, micro spring cloud concepts I want to use. I need to download the jar files. Instead of I am downloading the jar files, my build tool is going to download the jar files. Then developers will write the classes. Those are .java programs. We need to compile the Java program. For that, compilation required. This build tool will compile the Java programs. Once the programs are compiled, we need to test our code is working as expected or not by using JUnit. That unit test execution also will done by Maven. Once the unit testing is successful, Maven will package our application into jar file or war file. Maven will package our application into jar file or war file. This is the duty of the build tool. Once it is done, then all the developers code will be stored into one place, that is called as Git repository. The project source code will be available in one place. All the developers will be connected to the repository and they will store the project source code in the repository. Application will be stored in the repository. Every developer will have the access for GitHub repository. GitHub or Bitbucket. Earlier, people used it to work with the SVN. Nowadays, people are going for GitHub or Bitbucket. Now, application source code will be available in the GitHub repository. In the GitHub repository. What people will do in this GitHub repository? Repository source code integration. Code integration will happen in the repository. Then code monitoring, monitored access. Monitored access. Code integration will be available and monitored access will be available. Code integration means all the developers, nowadays developers are working from different locations. Work from home option is available. Now assume that currently I am working from my home. My team member is working from Chennai. One of my team member is in uh, what is that, Rajasthan. One of my team member is in the US. We all are working on the same project. I am developing some programs. My team members are developing some programs. At the end of the day, whatever the programs we develop as a developer, we are going to keep our code in the repository. Why we are keeping the code in the repository? To perform code integration. Every developer code should be integrated at one place. For that, we are using repository tool. Code integration will happen by using repositories. Either you can use Git repositories or you can use Bitbucket repositories. Then who is modifying the code? Who is updating the new code? Who is deleting the existing code? Who modified the code? Who, when, why, what? Everything will be modified by using this monitored access. Every repository will be maintaining, every repository is maintaining monitored access. Every repository is maintained by this monitored access. Code integration and monitored access will be available in the repository. Now, are you able to understand the purpose of first two tools, build tools and repository tools? Are you able to understand the purpose of build tools and repository tools in the Devops tool chain? Yes or no? Build tool we are going to use to create the project. Maven is a build tool. Gradle is a build. Guys, currently I am talking about Java tech stack. Maven is for Java projects, not for Python. Maven is for Java. Maven is a Java build tool. I'm talking about Java project. I'm not talking about .NET or Python. I'm talking about Java. For Java, we will use Maven as a build tool. GitHub, it is repository. You can store any project. It can be a Java project. It can be a .NET project. It can be a Python project. For any project, you can use GitHub as a repository. Maven is a build tool only for Java. Okay. What about the build tools for Python and .NET? That we will talk about later. Okay. Currently we are talking about Maven. Maven is a build tool for the Java. GitHub is a common for every technology. .NET project also can be stored in the GitHub. Python project also can be stored in the GitHub. Any technology project can be stored in the GitHub. GitHub is a central repository where we can store project source code. Now, so here, if people wants to start the project development, first they need to create a project folder structure. If people want to start the project development, so as we discussed in the SDLC, first they are going to get the requirements. They will analyze the requirements. They will plan the requirements. Once that is completed, then they have to start the implementation. In order to implement, they need to create one project. They need to download some dependencies for the project. They need to compile the project. They need to test the project. They need to package the project. For all these things, there is one tool which is used to automate build process of the application. What is build process of the application? All these things are called as build process steps. Project creation, dependencies downloading, project compilation, project unit test execution, project packaging. This is called build tools. In order to automate build process of the application, we are using one build tool. All the developers will use the build tool to perform these build activities. All the developers will use a build tool. Not only developers, even DevOps people also should know how to perform this build process by using build tool. That's why we are going to understand build tool first. How to create a project folder, how to download the dependencies, how to compile the project, how to unit test the project, how to package the project. All these things we have to understand. Once you are able to understand all these things, then how to store the code in the repository in the common place where everybody can access that code. That's where we are going to use GitHub repository, or you can use Bitbucket repository. What we will do in the GitHub repository or Bitbucket repository, we will integrate the code. All the developers code will be available in the GitHub, or the developers code will be available in the Bitbucket. In the Bitbucket, they are going to perform code integration, and that GitHub will maintain monitored access. Who modified, when modified, why modified, what modified, everything will be available in the repository. Okay, once this code is available in the GitHub repository, as a DevOps engineer, we need to deploy that code into our servers. Here, our servers will be available. Let's assume that I'm going to take my servers in the AWS. Let's assume that I'm going to take my servers in the AWS cloud. I can set up the application infrastructure. I will create EC2 instance in the AWS. In that EC2 instance, I will set up a server. I will set up a server. Now I want to deploy my application in the AWS cloud. In the AWS cloud, my server will be available. One server or multiple server. Let's assume that currently I'm taking one server in the AWS cloud in order to deploy my application. There is a server. This is my EC2 instance in the AWS. Don't worry, I will tell you how to create the EC2 instance, how to install the server also when I'm going to do the deployment. EC2 instance I'm going to take. In that EC2 instance, I'm going to install one server. What is that server? That is a web server which is used to run my web application. I'm going to take AWS EC2 machine. Inside that EC2 machine, I'm going to install one web server. Using that web server, I'm going to run my application. Using that web server, I'm going to run my application. Are you guys getting my point? Where is my infrastructure available now? Where is my infrastructure available now? Where is my server available to run my web application? Where is my server available? Where is my server available to run my application? Guys, could you please tell me? Where is the server available to run my application? My server is available in the AWS cloud platform. It can be in the AWS, or it can be in the Azure, or it can be in the GCP, no problem. Any one cloud platform. Currently, in our course, I'm going to use AWS cloud. I'm going to use AWS cloud to set up the infrastructure to run my application. Okay. Who created the project now? Who created the project? I am asking some questions. Please respond. Who created the project? Developers created. Which tool they used to create the project? Maven tool they used to create the project. Where is the source code of the, where is the code of the project? Where is the code of the project? Code is available in the GitHub. Where is the server available to run the project? Where is the server available to run the project? In the AWS. Server is available in the AWS cloud. Developers code is available in the GitHub. Server is available in the AWS cloud and code is available in the GitHub. Now here we need to perform build and deployment. Guys, as a DevOps engineer, what is your duty is you need to perform build and deployment. As a DevOps engineer, you need to perform build and deployment. In order to perform the build and deployment, here we are going to use one tool that is called as Jenkins. What is the tool we are going to use here? We are going to use one tool called Jenkins. Jenkins is heart of the DevOps. Jenkins is the heart of the DevOps. By using Jenkins, we can perform CI/CD operations, continuous integration and continuous deployment we are going to perform by using this Jenkins software. Are you guys able to understand? Development team is available. Development team is available. That a development team is using build tool and a development team is creating the project structure. Development team created the programs. Development team created the logic, created the code. They have compiled that code. They have tested. If everything is working, then developers will package the application, will run in the local system. Then finally, developers are going to keep the application code in the Git repository. Git is a central repository. All the project team members can access that Git repository. All the project team members can access that Git repository. That is fine. Now, once the code is available in the Git repository, as a DevOps engineer, we need to take the code from the GitHub repository and we need to deploy that code in the AWS cloud server. If you perform these activities, then it is called as DevOps operation. Development plus operations. Developers are doing the development. You need to perform the operation. What is the meaning of the operation? As a DevOps engineer, you need to take the code which is done by the developers and you need to deploy that code in the server. The server is available in the cloud platform. Taking the code from the repository and deploying that code into the cloud server is called as a deployment. Are you guys able to understand? Who will deploy the code into the web server now? Are we going to deploy the code into web server manually, or we are going to use a tool to deploy the code into web server? Come on, tell me. Are we going to deploy the code into web server manually, or we need to use some tool to deploy the code into that web server? We are going to use a tool to deploy the code into web server. Which tool we are going to use to deploy the code into web server? Which tool we are going to use to deploy the code into web server now? Jenkins we are going to use. Jenkins is called as deployment tool, CI/CD tool. Jenkins is called as a deployment tool, continuous integration, continuous deployment tool. Now, what this Jenkins is going to do? Guys, here, first, Jenkins will be integrated with the GitHub. Jenkins will be integrated with the GitHub. Why this Jenkins will be integrated with the GitHub? Why this Jenkins will be integrated with the GitHub? Can you tell me? What is the reason Jenkins is integrated with the GitHub? Why? For which purpose Jenkins will be integrated with the GitHub? To get the source code. Source code, developers are keeping the source code in the GitHub repository. Developers are keeping the source code in the GitHub repository. Now Jenkins has to take the source code. Jenkins has to take the source code. Take the source code by interacting with the GitHub. Then Jenkins is going to interact with Maven. Jenkins is going to interact with one more software called Maven software. In the Jenkins, we are going to in the Jenkins will interact with one more software called Maven software. Why Jenkins will interact with the Maven software? Already developers used Maven. Why Jenkins also should interact with Maven? Why Jenkins also should interact with Maven? Developers are going to keep the programs in the GitHub. Those programs should be compiled. those programs should be compiled. That code should be packaged as a jar file or war file. That code should be packaged as a jar file or war file. Then Jenkins software will interact with one more software called Sonar Cube software. Jenkins software will be integrated with one more software called Sonar Cube software. Why Jenkins will be integrated with the Sonar Cube software? What is the purpose of Sonar Cube software? To perform the code analysis, to do the code quality check, how the developers has implemented the coding, how the developers has implemented the coding. Is the developers implementing the coding with the proper standards or not? Developers are following the proper coding standards or not? How is the code quality? Code quality analysis will done by a software called Sonar Cube. Our Jenkins will integrated with the Sonar Cube also to perform code review. To perform the code review. Okay, now Jenkins need to do configuration management. Configuration management should be done for our Jenkins. Okay, that configuration management, whatever the configuration is required for our application, that configuration we can do by using one software called Ansible. But currently, forget about that configuration also. Let's understand the basic flow. Let's understand the basic flow. The very basic thing, if you want to implement a DevOps process for your project, these are the mandatory tools. Now, here, developers are using the Maven to create the project, to download the dependencies, to compile the project, to perform the unit testing, to do the packaging. Okay, once this coding is completed, developers are going to keep the code in the GitHub repository. Okay, so in the GitHub repository, all the developers source code will be available. All the developers source code will be available in the GitHub repository. Code integration and code monitored access will be available in the GitHub repository. Once the code is available in the GitHub repository, we need to deploy the code into AWS cloud. In the AWS cloud, I have taken one EC2 instance. In that EC2 instance, I have installed a web server to run my application. Now, code is available in the GitHub. Code I have to run in the web server. For that, I am going to use one centralized software called Jenkins software. Jenkins is CI/CD software. What is the duty of the Jenkins software here? Jenkins software will interact with the GitHub repository to download the source code. Jenkins software will take the source code from the GitHub repository. Once you have taken the source code from the GitHub repository, we need to compile the source code. We need to package the source code. For that purpose, we are going to integrate Maven with the Jenkins. Here, developers will do the compilation in their system. Developers will store the code in the GitHub. Whenever you download that code by using Jenkins, you should also compile that source code. You should also package that source code to deploy. Okay, so here in the GitHub repository, we are storing only .java programs. In the GitHub repository, only .java programs will be available. Source code is available. You will download the source code. You cannot run the source code directly. You need to compile the source code. You need to package the source code. For that, Jenkins will integrate with a Maven software, which is a build tool. Here, compilation and packaging will happen. Compile, package. Compile and package. Here, whenever you integrate Maven with the Jenkins, Maven is going to compile and package our source code. SonarCube is going to code quality check, code analysis, code quality check. Code quality check will done by SonarCube. Code quality check will done by SonarCube. When we do this code quality check by using SonarCube, if the quality is passed, then finally my Jenkins software will take the packaged code, whatever the code package happened by the Maven, whatever the package created by the Maven, that code package will be deployed into cloud server. That code package, whatever the code we have packaged by using Maven, that package will be deployed into web server. Finally, my application is running in the web server. Finally, My application is running in the web server. This is called as build and deployment process. Here, two things are available here, guys. Now, first thing, all these activities will done by developers. This first box, whatever is red circled, whatever is I'm circling with the red color, all these activities will done by developers. Now, all these activities will done by operations team. Development plus operations, it is called as DevOps, which is the main tool to perform operations in our application. Which is the main tool to perform operations in our application now? Jenkins is the main tool. That's why Jenkins is heart of the DevOps. Without having the knowledge on the Jenkins, can you do the deployments manually? Very difficult. So to automate application deployment process, we are going to use Jenkins software. Jenkins will be integrated with the GitHub. Jenkins will be integrated with the Maven. Jenkins will be integrated with the Sonar Cube. We are going to create the jobs in the Jenkins. Those Jenkins jobs we are going to execute. Here, guys, Jenkins software we are going to use to create the jobs. Jenkins we are going to use to do the build and deployment. Here, whatever it is doing by using Maven, it is called build. Package, taking the source code, compiling the source code, creating the package, then it is going to deploy that source code into server. Build plus deployment. Now, by using Jenkins, we are performing build plus deployment. Build will happen and deployment also will happen by using this Jenkins. Build and deployment I am doing by using Jenkins. Now, sir, how the build and deployment will happen by using this Jenkins? You can do the build and deployment by running the jobs in the Jenkins. Sir, can I achieve CI/CD? What is a continuous integration? What is a continuous deployment? Continuous integration, continuous deployment is nothing but here there is a developer modified some code and he committed that code into repository. There is a developer who modified some code and committed that code into repository. This developer modified some program in my application. He committed the code into repository. Whenever the code is committed to repository, immediately my Jenkins job is going to trigger. My Jenkins is going to do the building. My Jenkins is going to do the deployment. When developer modifies something in the GitHub, immediately Jenkins will detect that change and will deploy the latest code in the server. That is called continuous integration and continuous deployment. Generally, you can do this deployment manually. There is a job in the Jenkins. There is a job in the Jenkins. When you click, when you run this job, then build will happen, then deployment will happen. Manually, you need to run that job. What is there in the job? In that job, some script will be available, which will take the code from the GitHub, which will package the code by using Maven, which will do code review by using Sonar Cube, which is going to deploy the code into web server, which is available in the AWS cloud. So that is on-demand job execution. Hey, Ashok, I don't want on-demand job execution. I want to implement a CI/CD for my project. Continuous integration, continuous development. What is the meaning of continuous integration and continuous deployment? If some code is modified in the GitHub, immediately I want to deploy. If a developer modified some code in the GitHub, immediately I want to deploy. That is called continuous deployment, continuous integration, continuous deployment. In the Jenkins, I'm going to configure some webhooks. In the Jenkins, I'm going to configure some webhooks. What is the duty of the webhooks? This Jenkins will be listening to the GitHub repository. My Jenkins software will be monitoring the GitHub repository. If there is some change in the GitHub repository, immediately my Jenkins will take the build and deployment. That is called continuous and integration. Whenever you commit some code to the Git repository, whenever you change something in the GitHub repository, immediately my Jenkins is going to execute. My Jenkins will do the build process and my Jenkins will do the deployment process. That is called continuous integration and continuous delivery or continuous deployment, CI/CD. We are going to achieve that CI/CD process by using Jenkins software. So this is called development plus operations, DevOps. Understood? So now, as a DevOps engineer, what you are going to do in the company tomorrow, you are going to perform these operations in the company as a DevOps engineer. You are going to set up the infrastructure in the cloud. You are going to work with the Jenkins software. You are going to create the Jenkins jobs. You are going to integrate the Jenkins with the Maven to perform the build process. You are going to integrate Jenkins with the GitHub to download the source code. You are going to integrate SonarQube with the Jenkins to perform the code review. You are going to write the script in the Jenkins to deploy the code in the AWS cloud. All these things you are going to perform as a DevOps engineer. Developers will be available, operations will be available. By using this DevOps culture, we are going to collaborate development work and operations work in the project, that is called the DevOps. Understood? Understood what you are going to do in the company. So what is the main aim of our course now? Are you getting the picture? What the DevOps is going to do in the project? What you are going to do as a DevOps engineer in the company? Guys, all of you got some clarity? What is build process? What is CI/CD? And what is deployment process? What is build? What is CI/CD? What is deployment? Three things you need to understand here: build process, deployment process, CI/CD. Three terms I'm using. Build. Build means compiling the source code, packaging the source code. Deployment means take the package and deploy into server. Right. How to achieve CI/CD? How to achieve CI/CD? What I need to do? What I need to do to achieve CI/CD? What is the meaning of CI/CD? What is the meaning of CI/CD? Continuous integration, continuous deployments. When the code is modified, immediately I want to deploy. When the code is modified, immediately I need to deploy. Where we will configure that CI/CD process? In the Jenkins, we are going to enable webhooks. In the Jenkins, we are going to enable webhooks concept. What is the purpose of webhooks concept in the Jenkins? It is used to monitor the Git repository. It is used to monitor the Git repository. Whenever some code is modified in the Git repository, you take the code from the Git repository, you package that code, you deploy the code in the server. If code is committed, if some developer modify the code in the Git repository, immediately that code should be deployed to server. That we are going to do by using Jenkins. In the Jenkins, we are going to create the jobs. In the jobs, we are going to configure some hooks. Those hooks are going to monitor the Git. When something is modified in the Git, that means my code is modified, then immediately it will be deployed to server. Servers we are going to set up in the cloud platform by using AWS cloud. Samjha? What is the advantage of this process? What is the advantage of this process, guys? What is the advantage in this process? Automation. Automation. Fast delivery. Development team and operations team will work together. You are learning DevOps, that means you are going to work as a operational engineer. Operational engineer means you will be working with the DevOps. Okay. You are going to automate the things. No manual work. No manual work. We will do quality delivery. You will do quick delivery, fast releases, speed in the work. Your work will happen with quick releases, speed, quick releases, security, quality, reliability, collaboration, developers, operations. We are development operations happening collaboratively. When developer modifies some code, immediately that code will be deployed to the server. Quick releases. Quick releases will happen with this DevOps culture. So to become a DevOps engineer, what are the bare minimum tools you need to learn now? What are the bare minimum tools we need to learn now? First, we need to learn how to perform code compilation, code package. What is the first tool you need to learn? What is the first tool we need to learn? Maven. Because build tool, first we need to understand what is build tool, how the project will be created, how the code will be compiled. Okay, you don't worry guys. Basically, I'm a Java developer, so I have hundreds of Java projects in my laptop. I will give you several Java projects which are built by using Maven. I will tell you how to create a Maven project also. Okay, so we are going to work with Maven first. Once we understood Maven, how to create a project, how to download the dependencies, how to compile the project, how to unit test the project, and how to package the project. All this build work we will understand by using Maven. Once we understood Maven, what is the next tool we are going to learn? What is the next tool we are going to learn? Repository. GitHub tool we are going to learn. After Maven, we are going to learn the GitHub. That is a repository. Okay, why you need to know Maven as a DevOps engineer? Why you need to know Maven as a DevOps engineer, sir? Maven is a build tool. Developers will use now. Why I need to learn this Maven? I'm a DevOps engineer. Why should I learn the Maven? As a DevOps engineer, you need to compile the project. You need to package the project using Maven. Developers will store the code in the GitHub. After downloading the code from the GitHub using Jenkins, you need to compile that project. You need to package that project by using Maven. So you also, as a DevOps engineer, you should also know how to work with Maven. Project compilation, project packaging process will done by using Maven. Maven is a build tool. Compilation, packaging should be done by using Maven. Okay, once you do this Maven build process, then you need to perform the code review. You need to perform the code review. Which tool is available to perform the code review? SonarQube. Why we need to do code review? Why we need to do the code review? To check qualities. Okay. Once the code review is completed, then we need to deploy that code into server by using Jenkins. So guys, here I'm going to follow the same order. First, I will tell you Maven, then I will tell you GitHub, then I will tell you Jenkins, then I will tell you SonarQube. Once all these things are completed, then we'll talk about Docker, Kubernetes, Ansible, Prometheus, Grafana. All the remaining tools are very small. Terraform and all we are going to discuss. The main concentration we need to do first on the Maven, GitHub, Jenkins, SonarQube. After this, Docker, Kubernetes. After that, Terraform, Ansible, the Negios, the remaining tools are there. Bacha tools are there. Okay. The people who are not good in the Linux, we are going to conduct free classes for Linux. In the next week, we will start a Linux classes for you. If anybody want to attend those Linux, you can do. For the DevOps people, we will give the free classes on the Linux. Next week, Linux batch, other faculty will take the Linux classes. So some basics you will understand in the Linux, because first we need to understand Maven, GitHub, right? It will take 1 week to 10 days of time to understand the Maven and GitHub. By that time, your Linux basics will be completed. Then you can start the work with the Jenkins. By the time I start the Jenkins, you need to know the Linux, because the Jenkins I'm going to install in the Linux operating system. Every tool will be explained practically. Every tool will be explained practically here. In the real time, how we are going to use these tools, everything will be explained practically. Okay. Linux classes will be conducted separately, guys. Fine. Good. So with this, I hope you got the clarity. What is a build tool? What is a repository tool? What is a code review tool? And what is a CI/CD tool also? Build tool, repository tool, code review tool, code deployment, configuration. Ansible will be available for configuration management. Docker, Kubernetes. These are hotcakes in the market. Docker and Kubernetes are hotcakes in the market. We will discuss about those Docker and Kubernetes. Docker, Kubernetes, Jenkins, these three will take 1 month, guys. Docker, Kubernetes, these three tools will take almost a month of time. Okay. Next one, infrastructure as code. Infrastructure as code, that is by using Terraform. Terraform is the tool we are using to set up the infrastructure by writing the code. Infrastructure as a code. We will achieve that by using Terraform. Infrastructure as a code. Sorry, IASC. Infrastructure as a code we will achieve by using Terraform. But mostly our work will be available like this. Developers are writing the code. Developers use a build tool to write the code. Developers will store the code in the repository, maybe Git repository or Bitbucket repository. As a DevOps engineer, we need to create the Jenkins job. In that Jenkins job, we are going to download the code from the Git repository. We will compile and we will package the code by using Maven build tool. We will perform the code review by using SonarQube. Then we are going to deploy the code into server. Our server is running in the AWS cloud. Understood? Very good. Fine, guys. Thank you for joining.